Well, good afternoon, everybody. This is Dave Jones, Storm Center Communications and GeoCollaborate. It's good to be back after a few days off around Thanksgiving. It's Monday, December 3rd, and we have a couple of weather things to talk about. We have some lake effect snows. They're happening, tapering off a little bit, and then we'll be starting up again. And also another atmospheric river that could be threatening the coastline of Oregon and Washington and on up into Vancouver and western BC. But just want to take a moment to wish you and your family a happy Thanksgiving if you celebrated. And whether you do or not, if you got to spend some time together with friends and family, that's what it's all about. So take a look at this. This is the GOES satellite view. I have it in motion, and this is the visible sector, meaning when the sun shines down on the clouds, it reflects back. Different levels of reflectivity, different intensities of light, and we can see those as clouds. Where you see it dark, that's where the land is, where it heats up as well. But look at what's going on. Something I want to point out that's kind of cool. Right now you can see here later in the afternoon, the darkness is already approaching northern Maine. This is the terminator line where you see the sunrise and sunset. In this case, it's the sunset coming down from Maine. It'll be working its way down the east coast. That's what happens in winter. But I want to move just to the north a little bit. Look how the terminator line is kind of pivoting here, and you can see what's going on. This is the sunset line, and up to the North Pole, it's dark there. They don't even see the sun until sometime in January. So it stays relatively dark, although they do see light here. But you can see that kind of pivoting around because of the angle, that 23.5-degree angle that the Earth's on. And the sun is more focused on the southern hemisphere. And so that is why they have summer and we have winter in the northern hemisphere. But a lot of things going on. Look at this. Look at these clouds forming right over the Gulf Stream here because cold air is coming in across the land, and that forms clouds when cold air moves over warm water. And that's still the case as well when cold air comes out of Canada and moves over the relatively warm waters of the Great Lakes. Look at this. This is Lake Ontario. This is Lake Erie here. And we have been having a lot of lake effect snow because the lakes have been so warm. Let me take you a little bit closer to the mesoscale satellite sector. This is really neat. I'll take this full screen so we can focus in on it. Look what's going on here. You see clouds moving. Here are the Finger Lakes in New York. See clouds moving over top. Here is Lake Ontario here, and here is Lake Erie. Right in here is Buffalo, New York. And look, some of the white that you see not moving on the ground is actually snow that has accumulated on the ground because of the lake effect snows. And look at that. These streamers here, these have some pretty intense snow showers in them. These are bands of lake effect snows that set up. They're moving a little bit far away from the lakes now, so won't be accumulating a whole lot. But look at that. You can see them in the imagery, and they're extending all the way into northern Pennsylvania where there is snow falling and leaving this white behind. But here's what I want to do just for a moment. I want to focus in. There's some satellite imagery I brought into GeoCollaborate, and I want to show you what it looks like from the standpoint of snow accumulations from these lake effect snows. So we're going to be focusing right on this line right in here, and I'm going to switch over to GeoCollaborate here. So here we go. This we're now in GeoCollaborate. This is the latest mesoscale sector image, and look at this line. This is the demarcation line between all that snow and no snow. So here's Buffalo right in the middle. The southern suburbs of Buffalo, boy, they got pounded. And what are these dots? These dots are snowfall amounts that I've brought in from the NOAA snow measuring system. And look, these come from reports on the ground, cooperative reporters and things like that. Look in the northern sections of Buffalo here. Nothing. This is the amount of snow on the ground. Shows the elevation, latitude, and longitude there. But then if I travel just to the south, look at this, 17 inches of snow. That is not a far distance at all. Probably about a 20-minute drive, and you're in 17 inches of snow just south of Buffalo. If we work down a little bit to the farther, 22 inches of snow here. And I don't know if any of you had a chance, if you watched at all, that Buffalo Bills game when they played the San Francisco 49ers in Orchard Park. I'm going to zoom in just a little bit more here. Look at that. Here's the demarcation line between snow and no snow. Here is Orchard Park right here. They had about 28 inches of snow. Here's an observation here with 14 inches in East Aurora in New York, but it varied dramatically. But there was a band of heavy snow that developed around Orchard Park and gave them quite a bit of snow to deal with during that game. I'm going to switch over now too and show you some NASA satellite imagery. Again, here is Lake Erie. Here is Buffalo. I put the roads on here, and look at that. There is the snow line all the way over to Clarence, and nothing to the north. Now there's more over here to the northeast, but it's just incredible how much of a little difference it takes to make some snow. This is a satellite image that came in today, just a couple of hours ago, from the NASA satellite. They have an instrument on it called MODIS, which takes high-resolution images of the land and also of the clouds. And this is pretty cool. I just want to go down here for a second. Look at these wave clouds in the atmosphere here. That's pretty cool. Also over here, just south of Cleveland, look at these wave clouds. So if you're out and about in Cleveland and it's still light out, you'll see those streets of clouds. We call them cloud streets and wave clouds. Let's go over just south in southeast of Pittsburgh into western Maryland. Look at this. The wind hits those mountains and goes up and down and up and down and up and down. And when the wind goes up, it creates these clouds. And these are pretty stationary clouds. They're called, sometimes they look like roll clouds, but they're really lee wave clouds or standing wave clouds, mountain effect clouds. A lot of different names for them. Meanwhile, in Washington, D.C., in the Baltimore area, pretty clear. And one other thing I want to show you down here, and I'll back out just a little bit. Look at these clouds forming. When the cold air comes over the warm ocean, it forms more clouds. And look, looks just like lake effect. Well, that's because it is. It's called ocean effect clouds and precipitation. And sometimes you can get some pretty heavy snow falling out of those as well. So this is really, really cool. This is the mesoscale imagery again, showing more snow showers. Look at this. This is a heavy snow shower forming over the lake, getting ready to come into Pennsylvania. And this is going to be on the increase here over the next couple of days, where we're going to have another low pressure system moving to the north across the Great Lakes, getting pretty strong. And on Wednesday into Friday and Saturday, more lake effect snows are going to plague these downwind areas that are digging out, in some cases, of 4 to almost 5 feet of snow. Well, let's head out west. I want to show you what it looks like out west. You can see the curvature of the earth there and the sphere itself. We have, this is the moisture channel. Remember, we've talked about this before. This is the atmospheric moisture at the higher levels of the atmosphere, and as seen by GOES West. This is the satellite that's at 135 degrees west longitude and 0 degrees latitude. And so this is what we're looking at. We're looking at the moisture heading in towards the west coast. And this is the feature. This is the low pressure system and the feature that's going to evolve into an atmospheric river that could impact central northern portions of Oregon and the west coast of Washington. It doesn't look like it's going to be a serious one, but you know these atmospheric rivers can create localized flooding as well. And so Let me show you what that looks like. Yeah, even up here in western BC and Vancouver, you have some clouds and moisture, but there is some dry air trying to come into the picture there, maybe limiting some of the rain showers, so that's good. But this is what's heading towards the west Pacific Northwest that's going to cause a little bit of atmospheric river action. And so what I want to show you is the CW3E. This is a project out on the west coast that is working on atmospheric rivers and how those atmospheric rivers play a role, and they do play a big one, in bringing moisture into reservoirs all along the Pacific Northwest and the West itself, because, you know, we've had long-term droughts out there. We need this moisture from these winter storms, whether they're snow or rain coming in. And so now what I'd like to do is show you that model data. And so let's go over to that right now, and I'll show you what it looks like. And I want to focus in. Here is my cursor. You can see in the left-hand part of the screen, these are dots. And I'm going to take these dots and I'm going to pull them up into a different latitude and longitude. Okay, so I'm going to pull this one up into the green area. And you can see this green area is an atmospheric river intensity 2. I'd say a AR scale of 2 that is forecast to come into the west coast of Oregon. Now we can look over into this graph. Here is today in the dark black line in the middle of the graph. This is tomorrow, Tuesday, Wednesday, Thursday, and Thursday afternoon into Friday afternoon is when this atmospheric river, the AR2 on the scale, is forecast for this part of Oregon. So that's in the central to north central coast of Oregon. And we can move up. Watch, I'll move these dots up. And just a little bit further to the north, it looks like a little weaker atmospheric river. I'll take it back and watch this graph. See how it goes up a little bit into the moderate range. And, you know, moderate atmospheric rivers are generally beneficial. But when you've had a lot of rain already and the ground is saturated, it could cause some localized flooding. And you can see where this falls in this AR scale. This is the atmospheric river here, right on the border of an AR1 to AR2. So I wouldn't expect much in the way of disruptions out of this atmospheric river in northwest Oregon, but you do have to keep your guard up in case rain showers get heavier. Now I'll move up into Washington State here. Here we are, and it looks like that same atmospheric river is going to cause some issues late on the 6th. So here's Tuesday, Wednesday, Thursday, late on Thursday or Thursday afternoon into Friday morning. There could be some localized flooding. And then as we move on up into places like extreme northwest Washington, the atmospheric river gets a little bit weaker, but still can cause some localized flooding. More or less, it's going to be an AR1, which is primarily beneficial. Let's go up on into Vancouver and into Canada. You can see in British Columbia here, the atmospheric river comes a little bit sooner because of the land where it is and where the circulation around that low pressure is going to be. So that atmospheric river and the impacts will start likely Wednesday night around midnight, 1 in the morning, around midnight or so, going into Wednesday afternoon. And so that looks like it's not going to be very strong, but at least you'll be getting some moisture in there to help with the reservoirs. And look, we can go on up the coast here where we have some atmospheric rivers that are playing right now in parts of western BC and almost in extreme southeastern Alaska, where that atmospheric river is going on. That's a moderate one. Then there'll be a little break, and then this one coming again on Wednesday into Thursday. And so that's what it looks like from the atmospheric river standpoint. I want to show you now what it looks like from the GFS model. Okay, we'll go over to the GFS model, and I want to show you the northeast. So here's the GFS model because we talked about the lake effect snows, and it's going to get very windy across the entire Great Lake area. So we have impacts to critical infrastructure, impacts to roadways because of where it snows and locally heavy. Some roads will be impassable, but also combine that with the wind. We do have wind that's going to be blowing around snow where it snows, but also gusty winds that could impact tree limbs and trees. And I want to take you through this period. This is basically, this was valid 18Z Tuesday. That is the tomorrow afternoon. So this is tomorrow afternoon, and we're going to take this into motion. You can see by Wednesday afternoon, the lake effect machine starts to kick in, but not really incredibly heavy. We have southerly winds, southwesterly winds, so even downtown Buffalo will see some snow out of this. But then as we pull it a little bit forward in time, look at how this low pressure system, here is the frontal system. You see these kinks in the isobars? This is a frontal system that's going to be bringing in a lot colder air. And even in Maryland, southern Pennsylvania, this is rain. This is snow. So there will be impacts to travel and critical infrastructure, the highways, roadways, from eastern Indiana into Ohio, up into northwestern Pennsylvania, western New York, even throughout Vermont and New Hampshire and western Massachusetts. There could be some slippery conditions. And it only takes a half inch of snow. If it doesn't melt on the roadways, it can be very, very slippery. So let me take this on into the future, and you can see these, whenever these isobars get tight like this, that means strong winds because the atmospheric pressure is changing very rapidly. And so when the pressure changes, the wind goes up. And so that's what we're seeing here. Look at these winds coming in from the northwest, and look at these lake effect snows. It's going to pile up again. I'm sorry, those of you who are digging out of 3 and 4 feet of snow, you got some more coming. And that's what happens when the Great Lakes are not frozen. As soon as they freeze, bam, the lake effect snow machine turns off because there's not that moisture available. But until that happens, we have lake effect snows coming, and you can see that going on until Friday afternoon, and even maybe some lingering lake effect snows in northwestern Pennsylvania. But I want to back up just a little bit here because we do have the chance in the Maryland area, Baltimore, Washington, where it is raining, could see on Thursday some mixture of rain and snow, maybe even a little higher elevations turning over to some wet snow as this front comes through. But it won't be anything, just sort of conversational. That's how we describe it. But then when that front goes through, we get into the northwesterly winds, and then it clears out. Now, there's something else I want to show you too, and I'm going to back out just a little bit here. Here is the United States, right here. Here's Florida, where my cursor is. Here's Mexico, down the Yucatan Peninsula and Central America. And here is Alaska, right here. See the Aleutian Islands? It's a slightly different projection for this map, so I always like to orient everybody when I'm talking about this kind of forecast for this projection. Here's the Atlantic Ocean. Here's Greenland up here. Hudson Bay is right there. So this is the cold air that's over the East Coast right now, and what I'm showing you is the air temperature at about 5 to maybe 6,000 or 7,000 feet. It's called the 850 millibar level. That's how meteorologists, geeks refer to all this stuff. And so I'm going to show you, the neat thing about this is we can follow the cold air and the warm air as we go out in time. So as I move this, you can see this direct trajectory. Look at this, from Canada right into the mid-Atlantic states. So yes, it's pretty cold right now in the mid-Atlantic states, but as we take this forward, you can see what happens. The cold air concentrates again on Tuesday, that's December 3rd, and then on December 4th, We still are cold in the east, but look at out west. It starts to warm up. That's typically what happens. You have this dichotomy. You have cold in the east, warm in the west, or cold in the west and warm in the east. But this large area of cold air is going to get pushed out, but not before it gets reinforced by this next punch of cold air. Look at this. This is on Thursday. This is that frontal system we talked about coming through the mid-Atlantic states that could change some of the rain to some snow in the Washington and Baltimore areas on Thursday. Look at that cold air. That's going to come right in and punch through, but it's not going to last long because look, that rotates out. And then by Sunday, December 8th, Sunday afternoon, some warmer air starts to move into the east. And look at this. It kind of sticks around for a while. There's some cold air that tries to push it out of the way, but it sort of regenerates and builds back and wins. So even into most of next week, it looks like temperatures will be warmer in the east. But I want to point out a couple of things in GeoCollaborate here when it comes to the temperatures. And I'm just going to turn off here. I'm going to switch over to GeoCollaborate full screen here in just a second. I'm just going to turn off, well, you can see it here. I'm going to turn off this mesoscale satellite sector. This is the GOES mesosector. And here we go. There it is. So I'm going to turn that off to get that out of this picture here. And these are all of the snow reports that I read into GeoCollaborate from observers. And so we can click on any one of them up here, here in the UP of Michigan. Look at that. Units, 4.5 inches of snow right here. And I've superimposed it on the radar data. This is where it's snowing right now. So we can see different accumulations. But what I want to point out, you can also see some accumulations or snowing a little bit, the higher elevations of West Virginia. But I want to turn on the Climate Prediction Center's temperature forecast so we can see how that shapes up over the next 6 to 10 days and also where precipitation is forecast. So here I'm going to turn on one of the data sets from the Climate Prediction Center of 6 to 10 day temperatures. So I'll back out a little bit more here. There we go. Here are the 6 to 10 day temperatures. Looks like a fairly good chance of above average temperatures in this area over the next 6 to 10 days, about average temperatures here in the east. So compared to today, that's what the warming 850 millibar temperatures will result in. And then even up in Alaska, look at this. It's going to be warm. It's going to be this particular area above average temperatures, probability, 70% chance of above average temperatures in Alaska. Now, how about the temperatures 8 to 14 days in advance? So I'll turn off 6 to 10 day and go to 8 to 14 day future of what the temperatures look like. And look at this. Most of the nation will have the probability of above average temperatures. And look at Alaska. Still above average likelihood of temperatures over the next 8 to 14 days. Now, that doesn't mean they're going to be in the 50s, 60s, or 70s. It just means above their average temperatures. It looks like it's going to be a high likelihood of that happening. So that's what it looks like around the nation. And I'm going to pull back here and show you full screen one more time this western satellite loop, because we do have this moisture headed towards the west coast, likely result in an atmospheric river from about the north central Oregon coast on into Washington, into Vancouver. But it does look like it won't be a serious one. And for those of you that are interested in Hawaii and what's going on in Hawaii, here we go. We can zoom in a little bit. Sorry, let me go a little bit. Let me find Hawaii. There we go. It's fun to navigate around the world here and see what's happening. But here's Hawaii. There is some moisture around, but it looks like it's beautiful out there in Hawaii right now. So that's it for this particular update. I'm thankful that you joined me for this, and we're going to keep you posted over the next several days. I'll be back tomorrow, and we're working on a little update. I went down to Sarasota and Siesta Key over Thanksgiving and did a little video down there. I want to show you just what they're still dealing with because of Hurricane Milton and Hurricane Helene. Thanks so much for watching this update. We'll be back tomorrow with another one. I did travel down to Siesta Key and Sarasota over Thanksgiving and took a little video of what they're still dealing with as far as the damage from Hurricane Milton and Hurricane Helene. They're still recovering and will be for a long time. And we're also working on another couple things that we'll be bringing to these updates in the near future. So take care of yourself and take care of your neighbors. They really do appreciate it. We'll see you again tomorrow, and thanks for watching.